Hello everyone, my name is Aiza and my teammates are Azira, Afifa, Mas and Baizatul. And for this assignment, my group is going to present our app prototype called Ferment Optics. In the biofuels industry, one of the biggest challenges is inefficient microbial fermentation, which leads to low biofuel yields. This inefficiency arises from the inability to monitor and optimize key fermentation parameters like pH, temperature, and nutrient concentration in real time. Our solution is Ferment Optics, a powerful app designed to tackle this challenge. By providing real-time monitoring and visualization of critical parameters, Ferment Optics empowers operators to make data-driven adjustments, ensuring optimal fermentation conditions. This not only enhances efficiency but also maximizes biofuel production yield. With our app, we aim to bridge the gap between science and technology to revolutionize the biofuels industry.
My name is Afifa and I'll walk you through the login and dashboard screen of Ferment Optics, an app designed to simplify monitoring and management of fermentation processes. On the left, you'll see the login screen. At the top is the Ferment Optic logo, creating a clear and professional entry point. Below that, users can securely log in by entering their username and password in the provided fields. The design is simple and user-friendly with a prominent login button to proceed. Once logged in, the dashboard shown on the right offers an intuitive overview of key metrics. At the top, a quick summary displays the number of active tanks, like here with 3 active tanks. Beside that, core metrics are laid out clearly. Average pH to ensure optimal acidity, temperature to maintain stability, and nutrient level for proper fermentation health. These metrics are designed to provide actionable insight at the glance. At the bottom, users have a Start New Batch button for immediate action and shortcut icon for navigation appear consistently, giving access to features like monitoring, alerts, and reports.
I'm going to explain the monitoring page of our app. This page plays a critical role in providing real-time insights into the fermentation process. At the top of the page, you will see a drop-down menu that allows users to select specific fermentation tanks. This feature ensures seamless navigation when monitoring multiple tanks simultaneously. In the real-time data section, key parameters such as pH, temperature, and nutrient concentration are displayed in a clear-cut format for each tank. This makes it easier to track vital parameters at a glance. On the right-hand side, there's a line graph that visualizes real-time trends for pH, temperature, and nutrient levels over time. This graphical representation helps users identify fluctuations and make informed decisions to optimize conditions. Lastly, the interactive pause monitoring button at the top right of the page allows users to temporarily halt monitoring as needed, providing full control over the process.
Now I will explain about the parameter adjustment. It is a key feature of our system that empowers operators to adjust fermentation parameters in real time. The main purpose of this parameter adjustment is to allow operators to fine-tune fermentation parameters in real time. This will ensure optimal condition for fermentation, improving both efficiency and product quality. Operators can make quick adjustment to key parameters such as pH, temperature, and nutrient concentration. One of the key features is the header, which is at the top of the screen where we display the tank ID, for example, tank 1 parameters. There is also adjustment interface. It is a user-friendly adjustment interface and consists of 2 components, which is the interactive sliders for pH, temperature, and nutrient concentration. These sliders will provide a visual and intuitive way to adjust values. And there is also input fields, which is for precise adjustment. For instance, operators can directly input a value such as the set pH to 6.8 or the temperature to 35 degree. And last is the action buttons is included, which is to finalize or revert the adjustment. The save adjustment button is to change the applies the changes in real time. This is ensuring the updated parameters are immediately implemented. Second is the reset to default settings, which provides an option to revert all changes to the predefined optimal settings, which is useful for quickly recovering from errors or restoring baseline condition. Next, I will brief about alert notification, which is critical for maintaining operational safety and efficiency. The main purpose of this alert notification is to notify operators about out-of-range parameters and provide actionable insights for corrective measures. For example, if a tank's temperature exceeds the acceptable limit, the system will generate an alert along with suggested actions to resolve the issue promptly. One of the key feature is the alert log section. This section displays a list of both active and past alerts. Each alert includes detailed information such as timestamp and description. Second is its notification details. When an operator selects an alert from the log, they will see additional details like the problem description to explain the issue, such as tank 2 temperature has exceeded the safe threshold. And there is also the suggested action to resolve the issue, like lower the temperature by 2 degrees using the cooling system. Last is about the action buttons, which is to enhance usability. We have included action button known as acknowledge alert, which allows the operators to confirm they have seen and understood the alert. And then there is adjust parameter. By clicking this button, it takes the operator directly to the parameter adjustment screen where they can apply the recommended corrective actions. This button will streamline the workflow, reducing the time required to respond to issues.
Hello everyone, my name is Bagatul Umira and my metric number is 83358. Today I'm going to talk about the reports and the analytic. The purpose of these reports and analytic is to provide insights into batch performance and trend. Firstly, I'm going to talk about performance overview. Users can compare batch performance through visualized data like bar charts, enabling quick identification of inefficiencies. For example, as shown here, batch 1 achieved 85% yield efficiency while other batch varied. For the batch statistic, our app provides a real-time statistic on energy usage, water consumption, and carbon dioxide production and biomass yield. These metrics allow users to pinpoint optimization opportunities. For the export option, this app includes customizable export options, enabling users to generate reports in various formats like PDF, Excel, or raw data for deeper analysis. Another key feature is the historical performance metric view, where users can review past batch performance in a list format. These features allow operators to identify patterns and trends, like which batches consistently underperform. Historical data also supports predictive analytics, helping anticipate potential inefficiencies before they arise. While for the visual and functional design, as you can see in the video, it has a color scheme with shade of green and blue to represent eco-friendliness and scientific precision. For the icons for graph, notification, and tanks that make navigation seamless, a bottom navigation bar that provides quick access to major features like dashboard, monitoring, and reports.
This flowchart outlines the mechanism of our app designed for monitoring and optimizing biofuel fermentation processes. The workflow is divided into interconnected modules that work seamlessly to ensure efficiency and accuracy. The process begins with the login module. This ensures that only authorized users, such as operators or managers, can access the app. Next, the app collects fermentation data through two primary sources. First, manual data input. Operators can manually input data like batch information or specific observations. Next, sensor data input. Real-time readings such as pH, temperature, and nutrient levels are captured directly from fermentation sensors. Both manual and sensor data are processed and analyzed here. The app compares the data against preset optimal range and uses predictive models to identify potential issues. Once processed, the data is displayed on the dashboard, providing users with an overview of critical parameters and the status of ongoing fermentation processes. In this module, users can monitor real-time trends and graph for fermentation parameters such as pH or temperature. This allows them to keep track of any deviations. If an issue is identified, users can take corrective actions in the parameter adjustment module. For example, they can adjust the temperature or nutrient levels directly through the app. If any parameter goes out of range, the app sends an alert. Notifications include actionable suggestions to help users resolve this issue quickly. At the end of the process, users can generate reports summarizing batch performance. This data can be analyzed further to improve future fermentation cycles. Finally, the app allows users to export detailed reports in formats like PDF or Excel for sharing or record-keeping purposes. That's all from us. Thank you.